Hi class, today we're going to be doing 12.4 notes, which is our introduction to logarithmic functions. So first we're going to start talking about what a logarithm is. So what is a logarithm? The easiest way that you can think about this is a log is the exponent. Repeat that to yourselves a few times. The log is the exponent. If you can really get that in your head, that when we're asking you to find or evaluate a log, we're asking you to find the exponent, then logs make a whole lot more sense. And as we know, things all around us are exponential, like viruses are exponential functions, and we're definitely working with one of those right now. So, okay. The log is the exponent. So if I have, for example, a log base b of x equals a, for example, this, I'm going to use a different color here. This is what we call the base of the exponent. This is what we call the argument of the exponent. Or of the log, sorry, the base of the log and the argument of the log. And then this one over here ends up being the exponent to the base. So remember, if we think about the term is in math, the log is the exponent. Is means equals. So we can even think about it as the log equals the exponent. All right, so another way to think about that, if I was to kind of rewrite this as exponential form, we would have a base of b. So the base of the log is the same as the base of your exponent. The exponent of a equals the argument of the log. So that is a basic definition of what a log is. So let's look at some examples. Example 1 says evaluate the log base 2 of 8. So what I'm really asking you is I'm saying, okay, the base is 2. This, what I'm looking for, is the exponent to 2 that's going to give me 8. So I want to know 2 to the what power equals 8. And when you think about it, I know that 2 to the third equals 8. So my answer to this log, the log base 2 equals 3. So I can get rid of that, and I can say the log base 2 of 8 equals 3. So that's what a log is. Let's do another example. The log base 3 of 9 is question mark. Well, 3 to the what power is 9? We have a base of 3. I'm looking for the exponent to give me 9, and that would be 2. 3 squared is 9. Now, they won't all be quite so straightforward. We're going to throw a little bit of other exponent rules at you, possibly. So if we look at example 3, it almost looks like it should be a 2 because 5 squared is 2. But remember, this one is the base. So what I'm actually asking you is 25 to what power equals 5? And that's a little trickier to think about. So a couple things we need to remember. I can rewrite this. I can think of it as the square root of 25 is 5. I know that that works because 5 squared is 25. And that means 25 to the 1/2 power is 5. So I guess we can write just like a little note to ourselves. Recall that the square root of x is the same as x to the 1/2 power. We're also going to be using another rule here we'll write in a second. So, or you can think of it, if it's not the square root, if it's the nth root of x, that's the same as x to the 1/n power. So it doesn't have to be just a square root. All right, so the log base 25 of 5 is 1/2. All right, and then the last one, we want to figure out 3 to what power is 1/9. So again, we're throwing you a little bit of a curveball here. And when I want to create with exponents, I want to create fractions, we need to think about our negative exponents. So x to the negative n power is 1/x to the n. So anytime we have a base that's a whole number, I guess, an integer, and we have an exponent that we need to find so that it equals a fraction, that exponent is going to end up being a negative number. So 3 to the negative 2 power is 1 over 3 squared, which ends up being 1 over 9. So I'm going to have a negative 2 here. So if you look at the type of numbers I can have that a log can equal, there's a lot of options. I can have positive numbers, I can have negative numbers, I can have whole numbers, I can have fractions. All right, I guess there was one more really cool log we didn't talk about. So we saw whole numbers, we saw fractions, we saw negative numbers. What about 0? Can a log equal 0? Ooh, let's see. I've run out of room here. Let me just put it at the bottom. So can a log equal 0? Question mark. So let's think about this. If I say the log, let's just call it a base 2 of something equals 0, I wonder if this is possible. So if we rewrite this, if we think about what we're doing here, remember this here is the base, this one's the exponent. So if we rewrite those, 2 to the 0 power equals, is that a thing? Yes, it is. Anything to the 0 power is 1. So it is possible for a log to equal 0. It can equal positive numbers. It can equal negative numbers. It can equal fractions. Pretty much it can equal whatever it wants, which is pretty cool. Okay, so that's kind of just the basics of what a log is. Now, let's do a little bit more practice with converting between log form and exponential form. So log form is where you see that log, it has a base, an argument, it equals something. Exponential form, you don't see the word log for right off the top. You see a base with an exponent equals a number. So, log form. Let's look at the first one. Log base 3 of 9 equals 2. So if I rewrote this in exponential form, our base is 3, our exponent is 2, and this equals the argument of our log, which is 9. So 3 squared equals 9. Sounds right to me. Log base 3 of 27 is 3. I know that there's 2 different 3s, so let me just make sure that we know which one's going where. So this 3 is going to be blue. This 3 is going to be green. So the base of the log is this one. The exponent is this one, just to make sure we're all clear, and that equals 27. All right, now going from exponential form to log form sometimes is a little trickier. It takes a little bit more brain work. So I want to start with log, and then I want to write the base, and the base is going to be the same as the base of my exponent. So that's going to be a base of 4. And then I usually leave a space for a second, and I write the exponent next. So 4 to the 2 power, so my exponent is 2, so I know the exponent goes over there, and then my 16 gets filled in as the argument of the log. You can write it in any order you want, but that's what we end up with. All right, similarly, log base 4 of, and then I'm going to leave a blank, equals the negative 2 as our exponent, and then 1 over 16 is the argument of our log. And when you write these logs, it's really important to write the base smaller and lower than the rest of the line of your problem. So if we think about like writing on a line, the log, the argument, and the exponent piece should all line up nicely, and the base should be lower than those. So here we've got log base 49 of 1/2 equals, nope, that's wrong. Whoops, I'm not paying attention. All right, log base 49 of 7 equals 1/2. Make sure your exponent ends up on the other side of the equal sign. The log equals the exponent. All right, and that is it for basics of logs and converting between logs and exponential form.